Hello everyone, welcome back to my channel. In this video we'll be solving a numerical problem on direct step method. Direct step method is one of the methods for analyzing the water profiles in gradually varied flow. So this is a part of your non-uniform flow in open channels. So let's see the problem. A rectangular concrete canal has a slope of 0.0015, width of 7 meters and carries water at 15 meter cube per second. At the upstream end of a broad-crested weir, the depth is 3.8 meters. What is critical depth, normal depth, water surface profile type and length of the backwater curve? Okay, he's telling that there is a concrete canal in which water is flowing, and at the downstream side of the canal there is a weir placed, broad-crested weir. Okay, and he's telling that like for example, if your channel is like this, you have a broad crested weir placed like this. Okay, so there is water flowing in this channel. All right, so he's telling the depth of water is 3.8 meters at the upstream end of the broad crested weir. So for this broad crested weir, this left side is it's a upstream side, but for the canal it is downstream side. So he's telling that here there is depth is 3.8 meters, and he is asking us what is the water surface profile here at this 3.8 meters. How is the water profile looking like? And we have to also check for what is the slope, and then only we can decide what is the water profile. Okay, and he's also asking what is the length of the backwater curve. So what is this complete length he's asking? Okay, so once we can, if we determine the water surface profile type, then we can decide what is the length, or we can calculate what is the length. Okay, so now we'll start off with the problem. Let's write the given data first. Discharge is 15 meter cube per second given. Slope of the canal is given. Slope of the canal or channel means it is S0, which is nothing but the bed slope. We denote by S0. Okay, so S0 is equal to 0.0015, and width of the canal is given to us. So it's a rectangular canal, so width is B, which is 7 meters. So in this model of problem, the depth of flow or the normal depth is not given. Okay, so for deciding the water surface profile type, we require three parameters. One is given depth, that is this 3.8 meters. Next we have normal depth, and we have critical depth. So we don't have normal depth now. In some model of problems, normal depth will be given already. So since we don't have normal depth, first we should calculate normal depth. Then only we can calculate the what is the profile type based on these three depths into consideration. Okay, now we'll start off with the first question, critical depth. For critical depth, you don't require the formula of normal depth, or you don't require the value of normal depth. Okay, so we have the critical depth formula. I think you are aware what is critical depth. Critical depth is nothing but the depth of flow where the specific energy is minimum. Okay, so Hc is it is denoted by the symbol Hc. Hc is, the formula is q square by g whole power 1 by 3, where q is discharge per width. Okay, which is capital Q by B. So we have capital Q given to us in the question 15, by B is 7. So small q is 2.142 meter square per second. So now q is ready, we can calculate Hc. So Hc is, just substitute here in the place of q this value, 2.142 whole square by 9.81 whole power 1 by 3. So just solve in the calculator, you'll get Hc as 0.776 meters. So we are ready with the first unknown, critical depth. The second one was given to us was normal depth. As I've told you, the normal depth of flow was not given to us, so we should calculate that. See, your normal depth is nothing but in most economical sections and normally in open channels you solve, right, D. Generally we denote the depth of flow with small d. That d only is this Hn. There is nothing much difference. Okay, in when coming to non-uniform flows, when doing with specific energies and all, we denote the depths with H. Okay, so Hn is the normal depth. So for calculation of Hn, we have a formula. First of all, q is equal to, formula for discharge, q is equals to 1 by n. N is your Manning's n. 1 by n into a power 5 by 3 by p power 2 by 3 into s power 1 by 2. Here your n is your Manning's n, which is already given in the question. A is the area of the flow, p is the wetted perimeter, and s is the bed slope given to us. Okay, right. So what is the formula for area? You have to check for the channel geometry. In our question it is given that the channel is a rectangular channel, so formula is b into d, means width into depth of flow. As I've told you, generally we denote by d, right? So I have written for you for not getting confused. So which is equal to 7 into hn. The d is only nothing but normal depth, hn. I don't know the value of hn, so I will keep it like this. Next, p stands for wetted perimeter. You know, for a rectangle, wetted perimeter is given by the formula b plus 2d. So it is 7 plus 2 hn. Okay, right. Now I'll substitute the value of n, the value of q, the value of a, p and s in this equation, such that my only unknown will be hn. So I'll get, right, substituting the values of a, p, s, n in q. So I just substitute it and we'll simplify. So after simplifying, we will get the value of hn as 1.195 meters. Okay, it's a simple solving the value of unknown. Just take a calcium, you can start solving. Simple way of finding the unknown. Yeah. So hn is 1.195 meters. What was the given depth for us? They told, right, on the upstream side of the broad crested weir, the depth was 3.8 meters. That is the given depth, which is denoted by h. And what is the critical depth? hc. What we calculated using the formula q square by g whole power 1 by 3. This one. Okay, so we have hc. Just now we calculated hn, and in the question it was given about h. Now let's compare all the three values. See, now hn is 1.195 meters, h is 3.8 meters, hc is 0.776. So you observe what is greater in all the three? H, then hn, then hc. So we can write h greater than hn greater than hc. And this relation is for which type of curve, or which type of slope rather? It is a mild slope. Okay, the slope is mild. We have generally 5 types of slopes. According to that, we have the relations of h, hn and hc, and the slope is the mild slope. And also h is bigger than the other two values, hn and hc, so it lies in zone 1, and hence the water surface profile from these three is an M1 curve. This is what is important for us in determining the surface profiles. Okay, we can just go through the surface water profiles, then you'll understand what is M1, M2, M3, A1, A2, like that we'll be having. So you have to see, by observing these three relations, we have to check under which category our surface profile is. So according to this relation, our surface profile now is an M1 curve. This is what you need to write. Yes, asked in the question about surface profile, so you need to write. Now what is that is, he asked us, the next question was, what is the length of the backwater curve? He's asking what is the total length of how much this water profile is existing. Okay, see, we got normal depth. Just now we got 1.195. say somewhere our 1.195 is here. Okay, and on the upstream side of this broadcast weir, what was the depth? It seems 3.8. So here the depth is 3.8 on the upstream side of the broadcasted weir, and here our depth was 1.195. Okay, so from 1.195 meters to 3.8 meters, we have to calculate what is this length. Okay, so whatever we got this M1 curve, please try to understand, whatever we got this M1 curve will exist from 1.195 meters to 3.8 meters depth. This is not in length. So say this is 1.195 and say this is 3.8 meters. So our M1 curve will exist from here to here. Okay, so he is asking what is this length now. So that's what we need to calculate. Okay, so if this question is not given, length of backwater curve up to water surface profile type M1, you can stop the problem. But in general, they will not stop like that. They will ask you, sure, what is the length of the backwater curve? So for this, what I'll do is, I have this depth of flow here as 1.195 meters, and I have here the given depth 3.8 meters. So what I'll do is, this complete length I will break into intervals or segments. Okay, then for that, for easy solving purpose or for easy calculation, I will just break the entire length into small fragments or segments, or rather we call intervals. It depends upon how many intervals you choose. It's up to your own choice, but you have to choose a minimum of 4 intervals for accuracy purpose. So now for this problem I am choosing 6 intervals. Okay, so as I've told you, I am taking 6 intervals. So from 1.195 meters to 3.8 meters, each interval to be 0.434 meters. Nothing but the distance between two consecutive intervals is 0.434 meters. How this came is, so see here, I have 3.8 meters the given depth, minus where was my depth starting at 1.195. I decided 6 intervals. See, this 6 is arbitrary. You can decide how many intervals you want, but minimum is 4. Okay, don't divide less than 4. Start from 4 or 5 or 6, and it could increase also. So it is 0.434. 3.8 minus 1.195 by 6. If you are choosing 4 intervals, just divide this by 4. Okay, so now I'll put up a tabular column related to this 6 intervals, and I'll be showing you how to solve for length of the backwater curve. Please listen carefully. Before proceeding to the tabular column, just to have the look of these formulae. These formulae we will be using for completing the tabular column and for calculating the length of the backwater curve. So area formula, which is B into H. Next, wetted perimeter B plus 2H. These two values depend upon the channel geometry. For trapezoid, the values will change. This is for rectangle, so I have put the formulas for rectangle. Then velocity is Q by A. Why? Because Q is A into V. Next, we have hydraulic radius formula A by P. Here, in this direct step method, generally we write hydraulic radius with R. You can represent hydraulic radius either by M or by R, which is the A by P, area by wetted perimeter. Then we have specific energy, which is H plus V square by 2G formula. H is the depth or at the interval where you are calculating. That H plus V square by 2G. However, you will get this V from here, Q by A. Then delta E is nothing but it's the difference between two specific energies of two intervals. Then we have SF, which is the slope of the channel at that respective depth wherever you are calculating, which is given by the formula n into Q by A into R power 2 by 3 whole square. This n is nothing but your Manningson. Some represent by capital N, some represent by small n. Both are the same. Please don't get confused. Okay. Why? Because earlier I have just written capital N, here I have written small n. Don't think what is this. Everything is the same. N is, if you want, I am writing here n is equal to n, which is equal to 0.020 as given in our question. It's nothing but the notation. That's all. Next, SF bar. SF bar is nothing but the average of two SF values. For two intervals, we will take the average, that will be SF bar. Next is delta L or DL or delta X, which is nothing but the given by the formula delta E by S0 minus SF bar. Okay. As you know, S0 is nothing but the channel bottom slope. So like this, for every interval, we will end up in solving with delta L. So once you add all the delta L's for all the intervals, you will get the total length of the backwater curve. Right, this is our tabular column which we will be putting up. Just observe the tabular column. Observe the first column, which is H in meters, which is nothing but the intervals which we are taking. Second column is about A in meter square. As I've told you, the formula B into H. Third column is wetted perimeter, which is B plus 2H. That's the column. Next is hydraulic radius, which is A by P. Nothing but the second column by the third column. Next we have velocity, which is Q by A. Q value is already given to us in the question as 15 meter cube per second. By area, which you get from the second column, you will divide here. Then E, I told you specific energy, which is given by the formula H plus V square by 2G. H is this interval whichever you are taking, plus already V you will get from here. So V square by 2 into 9.81. Next I told you delta E, which is the difference of two intervals, these two intervals. Okay. Next is SF. As I've told you, SF is nothing but slope at this at the particular interval whichever you are considering. For every interval you will be having that particular slope. Okay. It means at every depth what is the slope. Then SF bar I told you, which is the average of two slopes. Then S0 minus SF bar we will calculate, such that we need the value of DL. As I've told you, DL formula is delta E by S0 minus SF bar. This value, delta E from here will be divided by this value. Okay. Now I'll explain each and every value in detail. Please try to understand and concentrate. Okay. As I've told you, we are dividing into intervals. See, the first depth was 1.195, right? Which was our what was this 1.195? our normal depth, right? So we started with 1.195, and I told you the distance between the two intervals must be 0.434. I told you how to get the value of 0.434, correct? So see, 1.195 plus 0.434, see, that is 1.629. That's my second interval. Similarly, plus answer plus 0.434. How much you got? 2.063. Like this, for every interval keep adding 0.34, and finally you will end up with 3.8, obviously, which is our given depth where we need to calculate. Like this you have to start writing the intervals. Hope you are clear. From normal depth keep adding the value of the interval. How we got the value? I am repeating once again. 3.8, the given depth they asked, minus 1.195, the normal depth from where we have to start by number of intervals. Okay, this is 0.434. So for every value from the beginning add 0.434. Perfect. Our first column is completed. Now second column is area. How to calculate area? I told you it's a rectangular channel, so the area formula is width into depth of flow. And remember people, when you are filling up this tabular column, it is with respect to that interval only. You should not get confused. Means, for example, if I want to write this area here, okay, now what was the formula I told you? B into H. What was B? 7 given to us, into what is H? 1.195, 8.365. see, this is the area. Similarly, see the second area. What will be second area? Again, area width into that particular height. See here, width is constant all the time, only height will change. So again 7 into 1.629, how much? 11.404. that's what I have written here. Like this 7 into, I mean the given width into this H will give you this area. Similarly 7 into 2.497 will give 17.4. like this, finish off this second column. Okay, let's go for the third column, which is wetted perimeter. The formula is B plus 2 into H. So B was 7 plus 2 into what is H here? 1.195, 9.39. like this, complete the wetted perimeter column also. Next comes hydraulic radius. What's the formula for hydraulic radius? A by P. So what was A? 8.365 divided by what was P? 9.39. okay, it is 0.8908, so I have taken it as 0.891. okay, like this, complete of this column also. Next comes velocity. What is velocity? Q by area. So Q was already given to us in the question, 15 by area, which you came from the second column. So 8.365, right, it is 1.793, which I have written here. Next comes specific energy. What was the formula for specific energy? I told you H plus V square by 2G. H is 1.195 plus what is V? Just now we got 1.793 square by 2 into 9.81, 1.3588. so I wrote it as 1.359. clear? Like this, finish off velocity column as well as specific energy column. So till here I think you will be very clear. For every interval you will be getting the values. okay, I am repeating once again. Area is B into H, width into that particular H, wetted perimeter again B plus 2H, so width plus 2 times that particular H. Then hydraulic radius A by P, this column by this column. Next is velocity, which is Q by A, Q already given in the question, by area, this column. Then E is H plus V square by 2G. H is this plus V square is from here by 2 into 9.81, you will end up. So I think you should first complete off this entire part. okay, for all the intervals you have to start solving up to E. I mean to say up to 3.816. like this you will get all the values. Maybe your value or your decimal may vary by 1 point, that side or this side, that doesn't issue. So like this you have to finish. For not to make a mistake anywhere in the problem, first complete off what I have told you. Now let's start off solving for delta E. What was delta E? I told you delta E is nothing but it is the difference of energy between the two intervals. So see here, our it's nothing but the formula E2 minus E1. Why are we writing E2 minus E1 is, as I've told you in the beginning of the problem, we were traveling upstream, right? If you observe this, I told you we were traveling upstream side, right? So hence we will do E2 minus E1. okay, when you're traveling downstream it will be E1 minus E2. And you may start off with any assumption. I am telling I'm traveling upstream, hence I'm doing E2, hence I'm saying that when I'm moving forward the forward value will be bigger, hence I'm doing E2 minus E1. but people may start like E1 minus E2 also. Once you do E1 minus E2, you'll get a negative answer, but again you have to end up with the conclusion that the water is flowing upstream. So hence I'm starting directly, I'm assuming that the water is flowing upstream side. Okay, yeah. Now see here, hence I'll calculate E2 minus E1. Why? Because first interval is here, second interval is here. When I'm moving upward means I'm moving towards right, so do E2 minus E1. So this minus this, so it is 1.717 minus 1.359. Right, I got 0.358. So whatever you are solving the difference of the interval, write it in between of the two intervals. Don't write parallel to, write in between. Similarly, I'll show you another example, the second interval, which is 2.118 minus 1.717, 0.401 or 401. Okay, what will be the third substitution? 2.535 minus 2.118. Yeah, 0.417. Like this, again the next calculation will be 2.959 minus 2.535. Next calculation, that will come out to be 0.424. Next one will be 3.386 minus 2.959, this value. Last one will be 3.816 minus 3.386, which is 0.430. Like this you have to finish, and remember you have to put it in the middles. Okay, now we are done with calculation of delta E also. Next comes SF. SF is nothing but the slope at that particular height or depth of water, whichever you are taking. Okay, so how I got this SF value? I have already told you the formula. SF is N into Q by A into R power 2 by 3 whole square. N is 0.020 into what is Q? 15 by, let me take for the first interval, I'm calculating the area. So for the first interval, what's the area? 8.365. So 0.020 into 15 by 8.365 into what was R for this? 0.891. So 0.8191 power 2 by 3 whole square. So for your purpose, for your for understanding, I'll just solve one and I'll show you. It is 0.020 into 15 by, what was A for us? 8.365 into hydraulic radius. Radius was 0.891 to the power of 2 divided by 3. And this answer square is what I require. 1.50 into 10 power minus 3. See here? Less. Like this you have to complete the SF column also. Okay. Once you are done with calculation of SF column, what's our next step? SF bar. What was SF bar? I told you average of 2 SFs. So 1.5 into 10 power minus 3 plus 6.2 into 10 power minus 4 divided by 2. Average of these two readings, which I have written with light blue sketch, that will be 1.05 into 10 power minus 3. Similarly, again take the average of these two interval. You'll get this two interval, this two interval, this, these two, and this, and for the last two you'll be getting like this. So I think you understood by now. Whenever we are taking the averages or whenever we are subtracting in between two intervals, you should write in the middle. So here you'll get it. Next comes S0 minus SF bar. S0 was already given to us in the question, right? 0.0015. So 0.0015 minus 1.05 into 10 power minus 3. You'll get this answer. Similarly, 0.0015 minus 4.53 into 10 power minus 4. You'll get this answer. Like this, complete this entire column. Next comes DL. I already gave you the formula for DL, which is delta E by S0 minus SF bar. So delta E is ready by S0 minus SF bar. So 0.358 divided by 4.5 into 10 power minus 4. I'll show you here. 0.358 divided by 4.5 into 10 power minus 4. 795.55. That's what I've written. Like this, complete this column. Again, next one will be 0.401 divided by 1.05 into 10 power minus 3. You'll get this answer. Like this, complete of this entire column. And at the end, I told you we want the length of the backwater curve, right? So the length of the backwater curve will be simply the addition of all these values. This DL represents length of the curve at this depth. Means the depth of 1.195 meters exists for this much of meters. Similarly, the depth of 1.629 meters exists for this much of length. Similarly, like that, when you come to 3.366 meters of height of water, there the length was this much. So finally, when you start from 1.195 and when you end up at 3.8, we should note the total length. So the total length will be simply the summation of the last column, which is 795.55 plus 381.90 and so on. Keep adding. The total length came out to be 2426.49 meters. Okay, so that's the total length of your backwater curve in meters. If you want, you can also write in kilometers. So how much it will be in kilometers? So it will be 2.42 kilometers, nothing but 2426.49 divided by 1000. Okay, so like this you have to end up the problem. So hope you understood this video. Thank you.